Hello everyone, welcome to Mathworld. This video is to discuss Cambridge International AS and A-Level Mathematics Paper 1, which is a pure Mathematics 1 for October-November 2019, and the code is 9709/11. So please like this video and like the channel if you enjoy watching my video, and also share this channel with your friends. Right, so if you would like to show support to this video, you may just click the thanks button just below the video. Alright, so thank you very much, and let's start the question now. So question number 1. Find the term independence of x in the expansion of 2x plus 1 over 4x squared to the power of 6. Okay, so basically this is the binomial expansion. Okay, but then I will just get the term, right? So for your information, this binomial expansion can be written as summation r from 0 to n. Then here is 6cn. Then a to the power of n minus, this is r. Okay, first term power r, then b to the power of n minus r. Okay, so this is the summary of the expansion, binomial expansion. So from here, I will just use the same method or same formula, just rewrite it. This is summation r from 0 to n. So 6cr. Okay, so I have a mistake here. This is supposed to be ncr. Right, so in general form. So therefore, first term 2x degree r, then the second term is 1 over 4x squared to the power of 6 minus r. Alright, so from here, since the first term you have x, right here you have x, this is also x, so I will bring in the power first, and then at the same time I split the constants from the x. Okay, so now we have a formula. If ab to the power of m, that is going to be a power m times b power m. You can just bring in the power. Alright, so which means now here I will get equals to summation r from 0 to 6. Okay, this is not n, it's supposed to be 6. Then here 6r. Then I bring in the r to the 2. That means that is 2 to the power of r. Then I bring the r into the x. It will be x to the power of r. Okay, then for the second term here, look at here. I have 1 over 4 x squared. So this part I can split it into two terms. That is 1 over 4. This is actually 1 over 4. Then x power negative 2. Okay, then now I will bring in the degrees as well. So it becomes 1 over 4 to the power of 6 minus r. Then the x squared you move up becomes x power negative 2 to the power of 6 minus r. Okay, so now I will simplify the x. So since here you have both x, right? So now we have another formula, which is a to the power of m times a to the power of n. So that is a to the power of m plus n. Okay, so from here, sorry. If I do not want to rewrite this summation, I will just write term independent of x. So term independent of x. This means constant. Okay, so constant means that the term with x degree 0. So when x degree is 0 on the right side, I get x degree r multiply with x degree negative 2 with degree 6 minus r. Excuse me. So from here, for the first one, right, I will use another formula. I mean, for this part, I will use another formula, which is a to the power of m, then another power outside. This is a to the power of m n. Okay, so that means now I will be getting x degree 0 equals to x degree r times x degree. This minus 2 you can just times into the 6 minus r. So I'll get negative 2 bracket 6 minus r. Then now, to combine these two terms, I will be using this formula. Okay, then now here, you will be getting, this is x degree 0 equals to x degree r plus. So negative 2 times 6, I get negative 12. Then minus 2 times minus r is plus 2r. Okay, so now same base for both terms. So I will just compare the degrees. That means now I get 0 equals to r minus 12 plus 2r. So on right side, it will be 3r. Then the minus 12 will be moved to the other side, becomes positive 12. So 12 equals to 3r. That means your r is 12 over 3, which is 4. That means the term independent of x happens or exists when r equals to 4. So now to find the term. So term independent of x right? So now you just refer back to here, replace the r in all these terms by 4. Okay, that will be the answer. Then you will get 15. So that is the solution for first question. Okay, now let's move on to question number 2. An increasing function. So when increasing function means f prime x is greater than 0. Okay, is defined for x greater than n, where n is an integer. Is given that f prime x is this expression. Find the least possible value of n. Alright, so now f prime x is given, which is x squared minus 6x plus 8. And now it's mentioned that f prime x is greater than 0. So now, right, you can just write increasing function. That means f prime x is greater than 0. Then from here, I will just write x squared minus 6x plus 8 is greater than 0. Okay, this quadratic function can be factorized using calculator or using this manual factorization. So x squared is x times x. Now, next is look at this. Minus, to get plus, minus times another minus is a plus. That means I know that both sign in the third column will be minus because of these two minus. Okay, so to get 8, and remember later on I need to plus the middle column. So it must be 4 times 2. Right, 4 times 2 is 8, or probably it's 1. It's 1 cannot because minus 8x, later on minus 1x, you get minus 9x. So now I need to get middle term is minus 6x. So now for the second column here, it will be multiplication of these two columns. So you will get minus 4x, minus 2x. Then now answer, first and third column you just times. You're getting these two terms. Second column is basically plus. Alright, so minus 4x plus minus 2x, that's why you are getting minus 6x. So for the factorization, just cross multiply. So this is the manual factorization. Otherwise, you can just press your calculator, get the root, then from the roots you change to factors. So here I get x minus 4 and x minus 2 greater than 0. So now to solve this inequality, because here is greater than 0, so now I will have sketch two graph, the curve of this. So the curve will intersecting at x equals to 4 and x equals to 2, because when you let these two be 0, you are getting x equals to 4 and 2. So now when you look at the coefficient of x squared here, this is basically 1, positive 1. That means this quadratic curve will have a minimum point. So now I will sketch my graph, simply sketch, and I know that the graph will intersect the x-axis at 2 points, x equals to 2 and 4, based on these two factors. So here, let's say 2 and 4. Final answer, okay, which is very important. For final answer, we refer to here. This is greater than 0. So when greater than 0 means it will be on the above the x-axis. Alright, so the region above the x-axis, or the orange color, that is greater than, x is greater than 4, or x is less than 2. So that's the solution of this question. Okay, oh, not finished yet, sorry. Okay, now here I found the x, but then you need to find out the least value for the n. So means that x is greater than n. Alright, so given x is greater than n, so now we have to choose x is greater than 4. Right, so x is greater than 4, therefore hence the least n equals to 4. Okay, so let's move on to question number 3. Now the line y equals to ax plus b is a tangent to the curve at the point 2, 6. Find the values of the constants a, b, c. So for your information, tangent means there's only, the line, this line just touches the curve. So when touches the curve means that there's only one intersection point. Alright, and then in other words, I would say that b squared minus 4ac equals to 0 when you are finding the intersection point. So now what to do is, okay, first of all, since this line is a tangent to the curve at this point, so I can just substitute this point into the curve first, because the point is also on the curve. Okay, now you need to find 3 unknowns. So now I will start with the curve equation. Okay, then now I will just write at the given point 2, 6. That means your x is 2, the y is 6. So now I will just replace. That means you'll be getting 6 equals to 2 times 2 cubed minus 5 times 2 squared minus 3 times 2 plus c. Then from here I can find the c. So basically, the first calculation, 2 times 2 cubed is 16. Then 5 times 2 squared is 20. Okay, then 3 times 2 is 6. Then plus c. So from here, your c is going to be 16. Right? So found the c. Now, we use this line. Given this line is a tangent, means that now I need to get, you can just use the b squared minus 4ac, okay, to show this tangent line, which means that is the intersection. So if I use that method, right, you will be getting cubic function later on. Alright, so no point to use this, because when you replace the y by ax plus b, here you still get cubic function. So don't use b. This is one of the way, okay, b squared minus 4ac, provided you get a quadratic. But now obviously we are not getting quadratic. Therefore, we have to solve this question using differentiation. Alright, so 2 options when you see tangent. So now I will write y equals to 2x cubed minus 5x squared minus 3x. C is 16, so plus 16. Okay, now tangent, another meaning is dy dx equals to 0. Okay, so now I will differentiate, and then I let dy dx be 0. Then now I will get my dy dx equals to, okay, when you differentiate, just for information, differentiate x degree n, it will be nx degree n minus 1. Alright, so then here you bring down the 3 and times with 2, that will be 6x squared. Then the 2 you bring it down and combine with 5, that will be minus 10x, then this is minus 3. Okay, so now we know that at x equals to 2, right? So now my gradient, so dy dx is my gradient of tangent, right? So I shouldn't say dy dx equals to 0, because when dy dx equals to 0, that is the maximum point. So this dy dx is basically the a, because this is a straight line. So the gradient is a. So now I will write at 2, 6, Right, so my dy dx, it will be 6 times 2 square minus 10 times 2 minus 3. So this is going to be 1. Okay, so this dy dx is the gradient of tangent. So now gradient of tangent, when you look at y equals to ax plus b, the a is the gradient of tangent. Okay, therefore a, I will write here dy dx equals to gradient of tangent equals to a. Therefore a equals to 1. Okay, so after we have found the a equals to 1, I can just rewrite my y equals to ax plus b. So it means that my y equals to ax plus b becomes y equals to x plus b. Okay, so then just for information, the concept for this graph is, let's say this is the curve, right? So this is the tangent line because you have a slope right now. So let's say this is the tangent line. This is y equals to x plus b. Okay, and it's mentioned that this line ax plus b is a tangent to the curve at the point 2, 6. That means the 2, 6 is basically on the curve and also on the line. Okay, so now after I have found the y equals to x plus b, whereby the a is 1, so I can just replace the point. Alright, so at 2, 6, so the y is 6, so 6 equals to x is 2. Replace the x by 2. That means your b is going to be 4. So with this, I have found my a is 1, b is 4, and then c equals to 16. Alright, so this is the working for this question. Okay, now for question number 4. A runner who is training for a long distance race plans to run increasing distances each day by 21 days. For 21 days. She will run X kilometer on day 1, and on each subsequent day she will increase the distance by 10% of the previous day's distance. On day 21, she will run 20 kilometers. First part, find the distance she must run on the day 1 in order to achieve this. Give your answer in kilometer correct to 1 decimal place. So because of increasing by 10% every day, that means this is the geometric progression. So I will write geometric progression. My first day is X. Okay, but because of increasing by 10%, now my R becomes 1.1 because 10% is basically 10 over 100. Okay, so it's 1 plus 10 over 100. Therefore, you get 1.1. If it just decreases, so 1 minus 10 over 100. So then now, on day 21, this is 20. That means T21, that is 20. Right. So now use the formula for geometric progression. So for geometric progression, Tn is AR degree n minus 1. This is a formula. Right. So I will just write here, Tn is AR n minus 1. So now here 20 equals to the A is X, R is 1.1, the N now is 21. So 21 minus 1 becomes 20. Therefore, my X is 20 divided by 1.1 to the power of 20. And now given 1 decimal place. So here it will be 2.9729. And to get 1 decimal place, look at here. I need to refer to the second decimal place. Since this is 7 and more than 5, so you round up. So when you round up, it will be 3.0. Okay, so that is the X. Now part 2, find the total distance she runs over the 21 days. So now Sn equals to A. Okay, now look at the R. R is 1.1. So since this is greater than 1, I will use R degree n minus 1 over r minus 1. Otherwise, you have to use 1 minus r degree n. We have another formula, which is a r 1 minus r degree n over 1 minus r. This is when the modulus r is less than 1. Okay, so now from here, I will just replace the a. Just now I have found 3.0. Right, so you just replace 3.0. Then r is 1.1, 21 days, so S21 here, so 21 minus 1 over 1.1 minus 1. And then here you will be getting 192. So done for the part 2 of question 4. Okay, question number 5, first part. Given this equation, show without using calculator that sine x equals to negative 2 over 3. So now I will rewrite the question first. Okay, so since sorry, since we need to show sine x, and now here you have tangent, right? So I will change the tangent x into sine x over cos x first. That is my first step. Then I will rewrite the rest. And now from here, I notice that the first and third term with the denominator of cos x. So I change my second term so that it has a denominator of cos x. Then I can combine all the terms, right? Because they are having the same denominator. So now what I need to do here is my first term, when you do expansion, it will be for sine x. Now for the second term, this 3 cos x is basically 3 cos x over 1. If I need to make it to over cos x, so I need to times cos x and divide by cos x. Alright, so it means that my numerator now becomes 3 cos square x. So when you multiply, so I will just direct change this to 3 cos square x, then plus 1 equals to 0. Okay, now this cos x in the denominator will be moved up, so but then it is still 0, right? So then here it will be 4 sine x plus 3 cos square x plus 1 equals to 0. And now since we need to show sine, right, sine x means that I should get the equation in terms of sine x. So then the cos square x will be replaced by identity. So we have an identity, cos square x plus sine square x equals to 1. Therefore, to get the cos square x as a subject, this sine square x will be moved to the other side. So I get cos square x equals to 1 minus sine square x. So then you will be getting 4 sine x plus 3 of 1 minus sine square x, then plus 1 equals to 0. Okay, and now do expansion. 4 sine x plus 3 times 1 is 3. Then 3 times minus sine square x, you get negative sine square x. Then plus 1 equals to 0. Okay, so I prefer getting the positive coefficient of sine square x. Therefore, I will move all these terms to the other side due to this is negative, right? So when I move I will be getting positive 3 sine square x. Then the positive 4 sine x change to the other, move to the other side, becomes negative 4 sine x. And then the 3 plus 1, it is 4. So when you move the 4 to the other side, minus 4. Okay, and now here I will factorize. 3 sine square x is 3 sine x times sine x. Okay, and again, look at here. This is minus. To get the minus over here, it must be multiplied with plus. Alright, so now, and since this is 4, so it could be 4 times 1 or 2 times 2. But then I need to get minus 4 over here. That means it will be 2. Okay, so I need to get negative 4. So here minus 2. This is plus 2. So that the middle term I get negative 6 sine x. Then the other one is 2 sine x. Then from here, you will get 3 sine square x and then minus 4 sine x, then minus 4. Okay, when you plus the middle column, then the factorization just cross multiply. Then I will be getting 3 sine x plus 2 times sine x minus 2. This can be done using calculator as well. Okay, so multiplication of two terms equals to 0 means that one of them must be 0. Either the first one equals to 0 or the second one equals to 0. Then now, sine x equals to negative 2 over 3, or the other one, sine x is 2. So we know that, right, sine x cannot be 2. Therefore, we have shown sine x equals to negative 2 over 3. Right? So that's the solution of this question. Okay, now part 2. Hence has misused the previous answer, right? Solve the equation. So basically, when you compare, just now 4 tangent x, 3 cos x, and 1 over cos x. So now here, 4 tangent x, your x has been changed to 2x minus 20, and 3 cos x, 1 over tangent x, right? So now here, what I need to do is I will just compare, right? So I will say that this is basically the answer from the previous part, but I replace the x by 2x minus 20. That means, okay, I will get this result. Sine of the new x is negative 2 over 3. Right, and now your x is from 0 to 180 degrees. Therefore, right, I have to get the new interval first. So when I times by 2x, it will be from 0 to 360 degrees. And then now I minus 20. So that means 2x minus 20 degrees. So 0 minus 20 degrees is negative 20 degrees. 360 minus 20 degrees, 340 degrees. So it means that now, for this expression, I can just accept the theta or the angle between minus 20 degrees to 340 degrees. So now by looking at the quadrant, okay, refer to the quadrant, sine is negative means that it will be in the third and fourth quadrant. So now I will write basic angle equals to inverse sine 2 over 3. So that is going to be 41.8 degrees, which means I will label this 2 as 41.8. Okay, now when you look at the interval right now, negative 20. So negative means you count the angle from the line, below the horizontal line. Alright, so obviously the first angle is not in the interval because the first angle is already negative 41.8. Now therefore you have to accept all positive angles, which means my first angle is basically the orange color and my second angle is the green color. Alright, so to get the orange color, that is 180 plus 41.8. So now here I will write 2x minus 20 degrees, that is 180 plus 41.8. Then for the green color, the green angle, that is 360 degrees minus 41.8 degrees. Then now, the first value is 221.8 and the other one will be 318.2 degrees. So now, to get the 2x, right, before you get the x, basically you need to find what is x. Before you get the x, you need to get 2x first, which means this minus 20 move to the other side becomes plus, right? So, which means 2x will be 221.8 plus 20. So I will get 241.8 degrees, and 318.2 degrees plus 20, that is 338.2 degrees. And then now all divided by 2. So when you divide by 2, that is going to be 120.9 and followed by 169.1 degrees. So that's the solution of this question. Okay, now next question, number 6. A straight line has gradients m and passes through the point with coordinates 0, -2. Find the two values of m for which the line is a tangent to the curve. And for each m, find the coordinates of the point where the line touches the curve. Okay, so basically, there are two parts. The first one is find the m values, alright, two values. And then the second is for each m, you need to find the point. Now, okay, so this is the the question whereby we apply the b squared minus 4ac equals to 0 just now. Okay, because straight line to the curve. Curve is a quadratic. So when quadratic, you can use discriminant method to solve it. So y equals to mx. Okay, I have to form the line first. Given the gradients m passes through 0 and -2. Alright, so line gradient m and then point 0, -2. So the equation of the line y minus y1 equals to m bracket x minus x1. So my x1 is 0, my y1 is -2. Right, so now you will write y minus -2 equals to m bracket x minus 0. So then from here I will get y plus 2 equals to mx. Hence my y equals to mx minus 2. So I let this be the first equation. And then my second equation is the curve. This is my curve equation. So y equals to x squared minus 2x plus 7. This is my second equation. Okay, so now I solve both equations. So first into second. I substitute first into second. That is the intersection point, which means mx minus 2 equals to x squared minus 2x plus 7. So move all the terms to right side and then let it be 0. So I will get x squared minus 2x plus 7. The mx will move, it becomes minus mx. The minus 2 becomes plus 2. Okay, then from here I will get x squared. Now look at this. This is minus 2x minus mx. I may factorize minus x, which is the common term from both of them. So minus x. Once you factorize minus x, the first term left 2 and the second term left the m. Okay, plus m. Alright, so 7 plus 2, it will be plus 9. So you are getting a quadratic equation, but in terms of m here, m and x. Therefore, we use the discriminant method. Now, for information, discriminant method, you must refer back to the general quadratic equation. Okay, then the discriminant is b squared minus 4ac. And in this case, because of tangent, means there's only one intersection point, therefore equals to 0, 1 real root. So from here, I will just write my a is 1, because 1x squared. My b is negative of 2 plus m. Then my c is 9. And now I will write discriminant b squared minus 4ac equals to 0. So just replace accordingly. Negative 2 plus m, this is my b, so I squared it, minus 4, a is 1, c is 9, equals to 0. Then from here, when you do expansion, the minus, you square it, is still positive. And then you can expand the 2 plus m using a plus b squared formula. That is a squared plus 2ab plus b squared. So it means that I will be getting 4 plus 4m plus m squared from the quadratic expansion. Then here 4 times 1 times 9, it will be minus 36. And I rearrange this and simplify. So I get m squared plus 4m. 4 minus 36 is basically minus 32. And now again, this can be factorized into m minus 4 and m plus 8. Okay, using this method. So here, plus and minus is minus. So this is minus and plus. Right? So use the same method for all the factorization. Then after that, just cross multiply. Okay, then from here, since the question says 2m, right? 2 values of m. That means now I'm getting my m values. So m minus 4 equals to 0, or m plus 8 equals to 0. So it means m equals to 4 or m equals to minus 8. So that's the first part of the solution. And now the question asks for each value of m, find the coordinates of the point where the line touches the curve. So for your information, alright, this the point, right, I would say that the point lies on the tangent line and also on the curve. So I will just substitute into the curve, right? Because your tangent line has m. So from here, I need to solve the simultaneous equation later on. So I will write from I will say that the intersection point, right? Because the point is basically the intersection point between the line and the curve. So then, since you have found the m, right? So I will refer to the m equation, which is this. I let this be third equation, right? So if I can find the x here, that means I will find the intersection point. So I will write from third equation, right? When m equals to 4. So now you replace the m by 4. So it means that I will get x squared, this is 6, minus 6x plus 9 equals to 0. Then here I will get 1 point. So then this can be factorized into x minus 3 squared, which means x minus 3 equals to 0. Hence my x equals to 3. Okay, so now from here, to get the y coordinates, you have two choices. Either you substitute back into the curve equation or the line equation. So I will substitute into line equation. That will be easier. So from first, my y is basically 4x minus 2. Then therefore, it will be 4 times 3 minus 2. That is 10. I get the first point. Alright, so now again, I will write here from third equation when m equals to minus 8. So I will just repeat this working. Alright, so now you substitute into here. M is minus 8. Minus 8 plus 2, it will be minus 6. Minus 6 together with the minus outside, it becomes plus 6. Right, so I will get x squared plus 6x plus 9. And this can be factorized into x plus 3 squared. Therefore, x equals to minus 3. So then, again, from first equation, just repeat the steps in this step. Okay, in this working. So y equals to minus 8x minus 2, because my m is minus 8. So therefore, you just replace the x by minus 3. Then you will be getting 22. Hence, right, I will write when m equals to 4, point equals to coordinates 3, 10, and when m equals to minus 8. The point with coordinates minus 3 and 22. So that's the solution of this question. Okay, now question number 7. The functions f and g are defined as this. Find the range of f and range of g. Okay, so now x is greater than 0. So fx equals to 3 over 2x plus 1. X greater than 0. So when greater than 0, to find the range, I just replace the x by 0 first. So f0 equals to 3 over 2 times 0 plus 1. That is 3. Okay, since this is greater than 0, means that you need to consider what happens when it tends to infinity. So now, when x tends to infinity, the denominator becomes a huge number. So 3 over a huge number, it tends to 0. So I will say 3 over 2x plus 1 tends to 0. Okay, so I know that my fx will be between 3 and 0. And this x value does not include 0, means that does not include 3. So which means my fx, my range f, okay, my fx will more than 0, greater than 0, and greater than 3. We will not include 0 because it will never reach 0. It's just approaching 0 when x approaching infinity. Okay, now for the gx. So for gx, that is 1 over x plus 2. And then the x is greater than 0. Alright, so now here, when you look at the 1 over x graph, right, this is the 1 over x. When x is greater than 0. So this is your y, this is x, here is 0. This is y equals to 1 over x. Now, when x greater than 0, this is from infinity until 0. Right? So, then from here, I know that the graph never touched 0 for the y value. Therefore, from here I will write, where x tends to infinity, 1 over x tends to 0, approaching 0. Okay, therefore, my gx will tends to 0 plus 2. That means it tends to 2 when x tends to infinity. Okay, so that means from here, I will say my gx, alright, will be greater than 2 because it will be this value onwards. Basically, if you want to sketch this whole graph, we are just moving up. That is translation. Okay, so moving up by 2 units. So it's like this. So that's why this is your y equals to gx. Here is 2. So it will be 2 onwards. So done for the first part. Alright, so from here I will write range G. Okay, now part 2, find the expression for f g x. This is a composite function and give the answer in this form where a, b, c are integers. So now I will rewrite first. Fx is 3 over 2x plus 1. And then gx just now was 1 over x plus 2. So f gx, that means that is f of 1 over x plus 2. This is your f gx. Now here, right, so what you need to do is you change your x in your fx into 1 over x plus 2. So then here, that means I have to change this x accordingly. Or in other words, my answer will be 3 over 2 times 1 over x plus 2. Then plus another 1 at the back. Then now, since we need to get this as the final answer, I will simplify my denominator first. So what to do is remainder 2 and change the terms inside the bracket to be the denominator of x, which means here over x 1 plus 2x, right? Then plus 1. And now I will get 3 over Okay, and again, this, right, you have two methods. So let's say I use the other method, which is easier. I bring in the 2 first. Right, I bring in the 2 first. So here I will get 2 over x. 2 times 2 is 4. 4 plus 1 is 5. This one is simple. So now I get the same denominator. So over x. So 2 plus 5x. Alright. Now for your information, this is 3 over means divide. 2 plus 5x over x. So if I want to change or divide into times, so you have to switch the position of the numerator and denominator. So it becomes 3 times x over 2 plus 5x. Okay, so I have to move up the x. Therefore, here is same as 3 times x over 2 plus 5x. Because we have a formula over here. A divided by B over C, it is same as A times C over B. That is the formula that I'm using. So therefore, you will be getting answer as 3x over 2 plus 5x. This is your solution. Okay, but then if you need to get this form, bx plus c, so probably I have to rearrange the denominator. That becomes 5x plus 2. Okay, part 3. Find the expression for the inverse of the composite function, giving your answer in the same form as in the part 2. Alright, so now I will let y be fg. That means your y is 3x over 5x plus 2. Now to get the inverse function, we get the x as a subject, which means now this 5x plus 2, I move up to the y. And then from here, I will get y times 5x plus 2 equals to 3x. And now I need to get the x as a subject instead of y. So for the left hand side, I will do expansion. That means you will be getting 5xy plus 2y equals to 3x. And now since we need to get the x as a subject, okay, so I will move the 5xy to the other side. Okay, then I will rewrite my right side first. That means you will be getting 3x minus 5xy equals to 2y. Then from here, factorize the x from left side. So you will be getting 3 minus 5y, that equals to 2y. And then your x is 2y divided by 3 minus 5y. So once you get the x as a subject, right, I will be getting the inverse function. So fg inverse equals to 2x over 3 minus 5x. So then that is the similar form in the part 2. Or if you need to get bx plus c in the denominator, what you need to do is probably you can write 2x over negative 5x plus 3. So that is your inverse function. Okay, now for question number 8. The diagram shows a sector OAC of a circle with center O. Okay, this is a sector. Now tangents AB and CB to the circle meet at B. Okay, so whenever you see tangents means that it will be 90 degrees. That's why here right angle. Right? Here also right angle. Now AC, the arc AC is the length of 6 and the angle AOC is 3 over 8 pi radians. First part, find the length of OA. What is this? Correct to 4 significant figures. Okay, so from here, since the arc length of the sector AOC is given, 6. So just for information, if this is a sector, here is theta, and radius is r. So the arc length is basically S equals to theta r. Okay, so I will use this to find the OA. So now 6 equals to my angle times OA, because the OA is the radius. Then from here, your OA is 6 times 8 over 3 pi. And now just calculate directly, correct to 4 significant figures. That is going to be, okay, then here you will just simplify 16 over pi. Then this is going to be 5.093. So that's the OA. Now part 2, find the perimeter of the shaded region. So perimeter of the shaded region is 6 plus AB and BC. So to get the AB, I will refer to triangle. Look at here. This is the triangle. Right angle triangle. Because we have found the OA just now. And this angle is half of the given angle. Therefore, I will just draw the triangle. Here O, A, and B. OA already found 5.093. This angle is half of the previous angle. That means this is half of 3 over 8 pi. Okay, so here I will write angle AOB. Half of previous angle. This is going to be 3 over 16 pi. So then my AB, I need to find AB. So basically from here, AB is the opposite side of the angle, and then the OA is the adjacent side. So opposite and adjacent, that is tangent, right? So tangent 3 over 16 pi is AB over OA. So now my AB equals to OA tangent. So OA is replaced by 5.093. Then tangent 3 over 16 pi. Therefore, this is going to be 3.4030. I give 4 significant figures here. No, I give more significant figures here. Okay, because this is the working. Now, so from here, since this triangle CBO and ABO are equal triangle, right? Because they are sharing the same line OB. That is the hypotenuse for both triangles. So which means BC is same as AB. So here I will write BC is same as AB, which is 3.4030. So now perimeter of the shaded region equals to AC, okay, arc AC, arc length of AC plus AB plus BC. So arc length is 6, then plus 2 times, or you can just write 3.4030 plus the same value. Then this is going to be 12.806, and now I round up to 3 significant figures, which is 12.8. So that's the solution of this perimeter of the shaded region. Okay, third part, find the area of the shaded region. So now, area of the shaded region is basically area of both triangles, right, minus area of the sector. So that is the area of the shaded region. So now I can find the area of the triangles. That are times 2. So since I have this triangle OAB, Just now I know that this is 3 over 16 pi, OA 5.093, OB already found 3.4030. So now I will just write area of triangle OAB, that is half of OA times OB, because this is right angle triangle. So 5.093 times 3.4030. Then this is going to be 8.6657. Okay, so then area of triangle OAB equals to area of triangle OBC. That is same value. Okay, so now I find the area of the sector. The sector is OAC. Okay, so now for your information, if let's say this is a sector, here's the R, this is theta, the area is half R squared theta. So now here, I will write this is half, R is 6, okay, because the OA is the radius. Then the angle is 3 over 8 pi. Therefore, the radius is not 6. The 6 is this length. The radius is OA, sorry, OA. OA is 5.3093. Half R squared theta. Right. So then from here you will get 15.2791. So then area of the shaded region that is area of triangle OAB plus area of triangle OBC minus area of the sector OAC. Then now just plus and minus, it will be 8.6657 plus 8.6657 minus 15.2791. Then you will be getting 2.05. Alright, so that's the area of the shaded region. Okay, now question number 9. The curve with this dy dx passes through the point. Find the equation of the curve. So for your information, if you are given y, to get dy dx, we differentiate. Okay, but now if it is opposite direction, from dy dx to get y, that is reverse process, which is the integration. Okay, so now we need to integrate. So it means that your dy dx is 5x minus 1 to the power of half, then minus 2. So your y, you need to integrate 5x minus 1 to the power of half, then minus 2 dx. So for the integration, we have a formula over here. Integrate ax plus b to the power of n dx. The answer or formula is ax plus b to the power of n plus 1 over the new degree, and differential ax plus b is a, followed by plus c. Okay, provided your n is not minus 1. Then from here, now I will get 5x minus 1. The half you plus 1 becomes 3 over 2. Then over 3 over 2. and then you differentiate 5x, I get 5. Differentiate minus 1 is 0. Therefore, this is your first integration. Okay, then the minus 2, remember, when you integrate, you always add 1 degree of x to the term. That means this is minus 2x, then followed by plus c. Now, for the denominator, this is basically 15 over 2. So 1 divided by, here is 1, 1 divided by 15 over 2 is basically 2 over 15. So now I will rewrite. This is going to be 2 over 15 times 5x minus 1 to the power of 3 over 2. Then minus 2x plus c. Okay, so now to get the c, replace the point. So 2 and 3. So add 2, 3. That means the x is 2, y is 3. I will get 3 equals to 2 over 15. Right. So 5 times 2 minus 1 to the power of 3 over 2 minus 2 times 2 plus c. Then from here, the first term on the right side, you will be getting 18 over 5. Then here, minus 4 plus c. So at last, your c is 17 over 5. So now, to get the equation of the curve, just substitute back the c into your curve equation just now. Okay, which means you just substitute this c into your curve equation. So then I will be getting y equals to 2 over 15 times 5x minus 1 to the power of 3 over 2 and then minus 2x plus 17 over 5. So that's the solution of this question. Now, part 2, find the second derivative. Okay, so for second derivative, I need to copy the solution from the dy dx from the dy dx first. Okay, so now I will rewrite this. So dy dx equals to 5x minus 1, 2 degree half, then minus 2. So when you differentiate, right, we have a formula over here. Differentiate fx degree n. The formula is n multiplied with fx degree n minus 1. Then you differentiate fx, that is f prime x. This is the power rule method, or power rule. Okay, what we call as power rule. So bring down the half, remain 5x minus 1. The degree instead of half, you change to half minus 1, which is negative half. Okay, so then from here, you differentiate 5x minus 1, that is 5. And now, since there is a negative degree here, right? So this whole term, I will move down. But then you still have 5 and half. So I will just write that is basically 5 over 2. Then now when you move down, ignore the degree negative, and then you still have degree half of 5x minus 1. That is square root 5x minus 1. So this is your second derivative. Now part 3, find the coordinates of stationary point. So stationary points means dy dx equals to 0. And show all the necessary working, determine the nature. So for the nature, you have to check the second derivative. So when second derivative is greater than 0, you are getting a minimum point. When it is less than 0, that is a maximum point. Alright, so now I will let this dy dx be 0 first to get the stationary point. So dy dx, the degree half I change to square root, and then stationary point, that means dy dx equals to 0. Okay, on other words, square root 5x minus 1 minus 2 equals to 0. So the minus 2 move to the other side. You will get square root of 5x minus 1 equals to 2. And now you square both sides. So when I square both sides, I will get 5x minus 1 equals to 4. Okay, then the minus 1 move to the other side, I'll get 5. Hence my x equals to 1. So when my x equals to 1, I need to get the y coordinates because of the coordinates of the stationary point. Therefore, I have to refer back. This is my y. Right, so I will have to copy this expression and replace the x accordingly. So my y equals to 2 over 15 times 5x minus 1 to the power of 3 over 2 minus 2x then plus 17 over 5. So when x equals to 1, just replace. So 5 times 1 minus 1, you get 4. And this is going to be 37 over 15. Then I get the stationary point. So stationary point equals to x 1, y is 37 over 15. So done for this stationary point. Okay, now when you look at the question, the second part is nature, right? So now I will rewrite this d squared y over dx squared. That is 5 over 2 square root of 5x minus 1. Okay, so now replace the x by 1. So at 137 over 15. My second derivative is 5 over 2 square root 5 minus 1. So 5 minus 1 is basically 4. So 5 over 2 square root 4. This is 5 over 4, which is greater than 0. So when it is greater than 0, my conclusion is 137 over 15 is a minimum point. Okay, so that's all for this working. Alright, now for question number 10. Relative to an origin O, the position vectors are given, okay, for 4 points. Show that AB is perpendicular to BC. The AB here means line, okay, BC also line. You want to show it is 90 degrees. So now what we do here is when two vectors, I will use vectors to show, okay. So when two vectors are perpendicular to each other, let's say here A and B, 90 degrees, so the scalar products will be 0. Okay, this is what I want to show now. So then I have to start with the vectors first. So vector AB equals to vector OB minus vector OA. So this is going to be vector OB 2 minus 3 5 minus 1 3 minus 4. Then now when you open the bracket, 2 minus minus 1 is 3, minus 3 minus 3 minus 6, 5 minus minus 4 is 9. Okay, found the AB. And then now I need to find BC. So my vector BC, that is OC minus OB. So this is going to be OC is 4, negative 2, 5, minus the OB is 2, negative 3, 5. Then this is going to be 4 minus 2, you get 2. Minus 2 minus minus 3 is 1. 5 minus 5, 0. Okay, so now I use the dots product. So AB dot BC, or scalar product. This is 3 minus 6 9 dot 2 1 0. Then now for the dots product, right, the calculation is simple. You just times the same component and then add the multiplication. So I'll get 3 times 2 plus minus 1 times minus 6 times 1 plus 9 times 0. Then from here, I will get 6 minus 6 plus 0, that is 0. So you will just write here, since AB dot BC equals to 0, right? Then vector AB is perpendicular to vector BC. Okay, so on other words, the line, when you change to magnitude, right? So when you change to magnitude, that will be perpendicular as well. Hence, because there's no arrow. No arrow means magnitude. AB is perpendicular to BC. Okay, so that is the working of this part 1. Now part 2, show that ABCD is a trapezium. Right, so trapezium means that I need to show that DC is parallel to AB. So now I need to find out what is my DC vector. So DC equals to OC minus OD. My OC from the question, 4 minus 2, 5, and then OD, 2, 2 minus 1. So 4 minus 2, 5 minus 2, 2 minus 1. And then this is going to be 4 minus 2, I get 2. Minus 2 minus 2 minus 4. 5 minus minus 1 is a 6. And I notice that I can factorize 2. So once I factorize 2, I get 1, negative 2, 3. And now I want to show that it is parallel to AB. So now I rewrite my AB first. My AB is 3 minus 6, 9. So now my AB is 3 minus 6, 9. And then I notice that from these 3 components, the 3 is in common. So I will factorize the 3. Then I will get 1 minus 2, 3. Okay, so then from here, I will just get the ratio, because I want to show that they are parallel to each other. So DC over BD. BC, sorry. Sorry. This over AB. Right, not BC. So when you divide, right? So when you divide, it looks like these 2 vectors will be cancelled off. That means I'm getting 2 over 3. Okay, so here I will just write 2 over 3. But then that is not the division of vector. It should be division of the magnitude. So here I have to put modulus. Right? That is 2 over 3. Or you can just write vector also, no problem. You just divide the vector. So cut. Right, cut the 1, negative 2, 3. So here I will say that DC, vector DC is 2 over 3 of vector AB. Okay, so now it is same as K of AB. So when you can express in this form, right, that means they are parallel. So from here, DC is parallel to AB. Therefore, the sides, okay, is parallel to AB. Hence, it is a trapezium. So ABCD is a trapezium. Alright, so done for this question. Okay, now part 3. Find the area of the ABCD, which is a trapezium. Give your answer correct to 2 decimal places. So now, okay, for your information, if let's say you are given the trapezium, okay, I just give you a general trapezium. The length here AB and the height is C. So the area is half of A plus B times C. So which means now I need to find out what is my BC length, the CD and the AB magnitude, right? So since we have found the DC and AB vectors just now, I will just find the length. So I will write down first. I need DC, AB, and BC. So BC already here, 210. BC 210. Okay, then I need DC and AB. DC and AB. DC is 4 minus 4, 6. DC. 4 minus 4, 6. And then DC is 2 minus 4, 6. Sorry, 2 minus 4, 6. Okay, and then I need another line, which is AB. AB, I take 3 minus 6, 9. 3 minus 6, 9. Okay, so now I need to find out the 3 lengths, 3 magnitude. So the length of the BC, or what we say that this is BC, that is square root of square all components and plus all together. So 2 square plus 1 square plus 0 square. I will leave it in square root first. That is square root 5. So my length of DC, vector DC, that is same as DC as well. This is square root of 2 squared plus minus 4 squared plus 6 squared. Then this is going to be square root of 56. Then magnitude of AB, this is same as AB, which is square root of 3 squared plus minus 6 squared plus 9 squared. And then you will be getting square root of 126. Okay, since now we have found the lengths, so area of the trapezium ABCD, that is half of, okay, DC plus AB times BC, right? So DC plus AB times BC. So just replace all these 3 values. So I get half of square root 56 plus square root 126 times the BC is square root 5. Then here you will be getting 5 square root 70 over 2. And now when you look at the question, it's mentioned 2 decimal places. So here I will get 20.92. So that's the solution of this question. Okay, now for question 11. The diagram shows a shaded region bounded by the y-axis, the line y equals to -1, and the parts of the curve for x at least 2. So now, first part, show or express this in the completed square form. Hence, for x at least -2, express x in terms of y. Okay, so first of all, we need to perform completing the square. So the conditions for the computing the square is make sure the coefficient for x squared is 1. So it's already 1 here, positive 1. So just rewrite first two terms. Then you plus square of two terms. So the term inside the bracket, it should be half of the coefficient of x. So this is plus 4. So I will write plus 4 over 2. Okay, then combine the first and third term. The third term will be the term inside the bracket. So here it will be x. Now the third term inside the bracket, that is plus 4 over 2. Plus 4 over 2 is basically plus 2. So I will write plus 2. Then you square it. So it will be minus 2 squared plus 3. That is going to be x plus 2 squared. So minus 4 plus 3 minus 1. So done for the first part. And hence, for x greater equals to minus 2, express x in terms of y. So y equals to x plus 2 squared minus 1. We need to get the x as a subject. So it means that this minus 1 move to the other side. And I write the x first. That will be y plus 1. And now to eliminate the square, I will take plus minus square root of y plus 1. Then now my x will be moving the plus 2 to the other side, so it becomes minus 2. Now here I will not write plus minus. I will leave it first. So then now how do I choose a plus or minus? Look at here. Your x is greater equals to minus 2. Right here. Your y value, okay, your y value is greater equals to minus 1. Right? So when x greater equals to minus 2, my fx, is that the fx, or my y? Okay, my y is greater equals to minus 1. So now this means this is actually the domain. Okay, this is the domain for the y. This is a range, right? The domain for the graph, this is a range. So basically this x later on, right, this is basically to find the inverse already, right? Inverse function. Okay, so the inverse function range, this is the whole range of inverse function. It will be the domain of the original function. So it should be at least minus 2. So in order to get at least minus 2, therefore here I have to choose plus. Because if you choose minus, it will be less equals to minus 2. It will be more negative. Okay, so that is how we choose plus or minus sign. Clear? Right? So done for that question. Now part 2. Hence, show all necessary working. Find the volume obtained when the shaded region is rotated through 360 degrees about the y-axis. Okay, so now refer back to the diagram. So you are rotating this region for 360 degrees about the y-axis. So when you rotate, right, so formula is v equals to pi x squared dy. Then the x value will be from minus 2 until 0. Oh, sorry, we are not looking for the x value because here dy. We are looking for the y value. So the y value from minus 1 to 3. My mistake just now. Minus 1 to 3. Okay, because we are integrating with respect to x, with respect to y. So then I will just write my volume equals to pi integrate from minus 1 to 3 x squared dy. Okay, so now what is my x? What is my x squared? So basically, we have found the x just now. Okay, so just copy this, minus 2 plus square root y plus 1. So this is pi integrate minus 1 to 3 minus 2 plus square root of y plus 1. Then you square it, dy. And now here, I will do expansion a plus b squared equals to a squared plus 2ab plus b squared. That means this is going to be pi integrate from minus 1 to 3. So when I square minus 2, it will be 4. So minus 2 times square root, it will be minus 4 square root. Then you square the square root, it will be just without the square root. Okay, this is what you get. So now when I integrate, before I integrate, I will change the square root first. So it will be 4 minus 4 times y plus 1. The square root becomes degree half. Then plus y plus 1 dy. Then now here, okay, for integration, I have introduced the formula just now. Ax plus b degree n dx, that is ax plus b. Instead of degree n, now you change to n plus 1 over n plus 1. And when you differentiate ax plus b, that is a, followed by plus c. So here I will get 4 change to 4x, remain the 4, rewrite the function. The degree instead of half, now you plus 1 becomes 3 over 2 over 3 over 2. Then plus the y plus 1, I can group it together and then apply this formula. That means this is y plus 1 squared over 2 and differentiate to the y plus 1, it will be 1. Now if you do not prefer this grouping method, you can just treat this as 2 terms and then you integrate, it will be y squared over 2 plus y. That is another option, right, for the integration. So then now I just consider the limits. So substitute the y, or before I substitute the limits, I will simplify first. Look at here, 4 divided by 3 over 2. So you move up the 3 over 2, it becomes 2 over 3. So 2 over 3 times 4, it will be 8 over 3. So I will get pi pi times 4x minus 8 over 3. Okay, so probably I rewrite. Then y plus 1 with degree 3 over 2. Then the over 2 here I can take out and change to half. Or you want to remain in that form, also no problem. Okay, so now I will replace my x, this shouldn't be x, this is y, because I integrated with respect to y. Okay, so now you replace the y by 3 first, which is the upper limit. So I will get 4 times 3 minus 8 over 3. So 3 plus 1 is 4. Then again, 3 plus 1 is 4. Then you minus when the y is replaced by minus 1. So 4 times minus 1 minus 8 over 3. So minus 1 plus 1 is 0. And then the other one is also y plus 1, which means it's 0. So then from here, you will be getting, the first one is 12. The second term, you will get 64 over 3. Then half times 4 squared, that is 8. This minus, bring it in, it will be plus 4. And the other two terms are 0. So at last, you will be getting 8 over 3 pi. So that is the solution of this question. Okay, so I have come to the end of the video. Thanks for watching. Please like this video and like the channel if you enjoy watching the video, and also share this channel with your friends, right? So to show support to this channel, you may click the thanks button below the video. Alright, and stay tuned for more upcoming videos. Thank you everyone. Bye.